Hello everyone, welcome to CodeWeb India. So in today's video, I'm going to show you how to solve this lead code problem number 700, search in a binary search tree. So it says here that we are given a root node of a binary search tree and a value, and we need to return the first node in this particular BST that the node's value is equal to the given value, and we need to return the subtree. So basically we need to return something like this. We need to return the node so that this particular function can construct a binary search tree like this. Okay, so how are we supposed to get this node? So let's first talk about how do we approach this problem. So we are given a binary search tree and we need to search something. So in order to first we have to understand how to search in a binary search tree, or let it be any binary tree. We have to iterate basically over all the nodes that are present in this binary search tree. So how do we approach this problem? Let's just say that I'm currently having the access to this particular node 4, and I need to search whether 2 is present or not. So my first basic instinct or intuitive approach would be to basically compare these elements. So if 4 is equals to 2, I do nothing. I basically return this particular node, right? But what happens when these do not match? How do we, you know, approach to the next iteration? Where should we go? So either we go to the left child, or what should we do? Go to the right child. So this is basically where the binary search tree part comes in. So binary search tree is a special type of a binary tree which has a property, and that is a very important property actually. It states that all the nodes in this left subtree of a root node will be always be less than the value of the root, and all the nodes that are present in the right subtree of a root will always be greater. So imagine that we first check that if the value of 4 is equals to 2, we do nothing, we basically return the element. But if 4 is not equal to 2, so it must be either be greater than 2 or it should be less than 2. So in this particular case, 4 is greater than 2. So we know that the root node is greater than the value that we need to search. So it cannot exist in the right subtree. So basically traverse to the left subtree. Okay, we basically ignore this part. So we are not going to every element of the tree. So it is very fast as when compared to basically traversing every node of a binary tree. Then we go to this node. We again check whether this node is equal to this node. Yes, it is. And this is a very best case scenario. Then we do nothing. We basically return this node. Okay. So let's just code it out. So first thing, base case, always remember, if root is equals to null, we basically do nothing. We return the null. But second case, let's just not take a temporary node that is equal to root node, and let's just traverse that particular node. So this node we basically will use to compare each element temp. So this is temp, then again temp will go to this and whatever the basically tree is. So first condition that I told you, we need to check whether this element's value is equals to the value you need to search. If that is true, we basically need to return the temp. So what I did here is actually very simple. I just basically compared each element 4 to 2 and check whether they are equal or not. So if they are not equal, we basically need to put a comparison that if it is greater than value, if the current value is greater than the value, obviously it won't exist in the right subtree. So we need to go to the left. Else if it is greater, we basically need to go to the right of the tree. And finally, if all these conditions fail and we do not get the condition where we have the value equal to that value, we basically return null. So this means that we are not able to find the element in this binary search tree and it does not exist. So let's just run this code. Okay, it is working fine for this particular case. Let's hope it does for the entire test cases. Yes, it does. Okay, so this is a very simple problem that we just did, and it basically is important to do these kind of problems because whenever you want to apply for any kind of interviews, you are rejected on basis of these problems. If you are not able to solve easy problems, you'll basically be rejected. So obviously the interviews will be based on if you are able to solve on medium questions, but I highly recommend that you solve the easy ones first. So I hope you like this video. Thank you so much.